ever wondered how our universe expanded after the Big Bang? The most popular explanation comes from the inflation theory. This theory, born out of the brilliant mind of physicist Alan Guth, was conceived to solve some of the universe's biggest mysteries. It seeks to explain the flatness of space and the near-perfect uniformity of the cosmic microwave background radiation, or CMBR for short. According to inflation theory, the universe underwent a rapid expansion right after the Big Bang, growing exponentially in size. This massive growth spurt ironed out any potential wrinkles in the fabric of space, resulting in its observed flatness. The theory also accounts for the uniformity of the CMBR, the afterglow of the Big Bang, by suggesting that all parts of the universe were once in close proximity, sharing the same physical properties before this grand expansion. So, inflation theory seemed to have all the answers, but as we'll see, it wasn't without its problems. But what if this widely accepted theory is flawed? What if it doesn't hold up under scrutiny? Let's dive into some of the criticisms and failures of the inflation theory. In a 2021 article titled "Blowing Up the Universe, Bicep 3 Tightens the Bounds on Cosmic Inflation," researchers combined data from prior experiments, including Bicep 2, Keck, WMAP, and Planck, to put the tightest bounds yet on what kinds of primordial gravitational waves could be out there. The results ruled out a number of inflation models, including some popular older models and some versions of newer ones motivated by string theory. This suggests that the inflation theory may not be as robust as we once thought. Physicist Brian Miller further challenges the theory by explaining why the Borde-Guth-Vilenkin theorem has disproven attempts to find a loophole for the conclusion of a cosmic beginning by appealing to the theory known as eternal chaotic inflation. This theorem argues that any universe, which has on average been expanding along its history, cannot be infinite in the past, but must have a past space-time boundary. But perhaps the most damning criticism comes from one of the original architects of inflationary cosmology, Paul Steinhardt. He later rejected the theory for reasons he detailed in his Scientific American article, "Pop Goes the Universe." Steinhardt argued that all the major predictions of the simplest and most tractable versions of inflationary theory have failed. Current versions are so contrived and flexible that they could fit nearly any data, and therefore they have no real explanatory power. Steinhardt and colleagues suggest a more fitting term to describe the outcome of eternal inflation is a multi-mess, as it fails to predict the properties of our observable universe accurately. As Steinhardt pointed out, the theory of inflation might be more of a multi-mess than a solid explanation. The search for a comprehensive understanding of our universe's formation and growth continues, reminding us that in science even widely accepted theories are subject to scrutiny and revision. But what does this mean for our understanding of the universe? And how does this relate to ancient biblical texts? In the realm of theoretical physics, the extension of Gödel's incompleteness theorem into quantum physics presents a significant challenge to our understanding of the universe. The theorem suggests that even a flawless and comprehensive description of the microscopic properties of a material will fall short of predicting its macroscopic behavior. This essentially implies that the inflation theory, despite its intricate details and complex computations, will forever remain incomplete. It will perpetually fail to fully explain the fine-tuned flatness of space and the near-perfect uniformity of the cosmic microwave background radiation, key mysteries of our universe. Interestingly, these concepts, seemingly out of reach for modern physics, find echoes in ancient wisdom. The Bible, a text thousands of years old, carries verses that strikingly align with these cosmic phenomena. In the book of Job, chapter 38, verses 4 and 5, it is written, "Where were you when I laid the earth's foundation? Tell me if you understand. Who marked off its dimensions? Surely you know. Who stretched a measuring line across it?" This biblical passage suggests an understanding of the flatness of space, a concept that challenges our most sophisticated scientific theories today. Similarly, in Proverbs 8, verses 26 and 27, we find, "While as yet he had not made the earth or the fields or the primeval dust of the world. When he prepared the heavens, I was there. When he drew a circle on the face of the deep." This verse mirrors the uniformity of the cosmic microwave background radiation, an aspect of the universe that continues to baffle scientists. Perhaps our understanding of the universe isn't so far removed from the ancient wisdom after all. As we continue to explore, we must remember to question, to scrutinize, and to keep an open mind. So, what have we learned today about the universe and its origins? We've delved into the inception of inflation theory, its criticisms, and its theoretical implications. We've seen how even one of its original architects have now rejected it due to its lack of explanatory power. We've also explored how biblical predictions align with our observations of the universe. The quest to understand our universe is ongoing, but it's clear that some of our most widely accepted theories about how our universe came to be might not be as solid as we once thought. Keep questioning, keep exploring, and remember, many times even the most brilliant minds of science, such as physicist Alan Guth, are often shown to be wrong in their theoretical predictions.